to be the integral. So for example number 6, we're given x cubed sine of x dx. We use the tabular integration method, which is really, the reason that we use this method is we're really doing integration by parts. But for whatever reason, when we integrate by parts, this integration has to be integrated by parts and integrated by parts. So this integration by parts doesn't go away right away. And so there's a pattern that emerges because this second part is based on two things. One, it's based on the derivatives. And then we do the integration. So if we keep using the same u and the same dv, a pattern will emerge. And so we could just, instead of writing it out, we could just use tabular integration. So now the way this works is I'm going to say x cubed, take the derivative, which is 3x squared, take the derivative, which is 6x, take the derivative, which is 6. Now, for my integration, I'm going to start with sine of x. What's the integral of sine of x? Negative cosine of x. What's the integral of negative cosine of x? Negative sine of x. What's the integral of that? Cosine of x, right? And we got to go all the way down to 0. And that was the other mistake that I made. We go all the way down to 0. And so we start back over with sine of x. Now the way this works is, by integration by parts, I'm going to have, let's change the color of that. I'm going to have this pattern that emerges where these are the u's and v's of the integration by parts. So the first time I do this, I'm going to get x cubed times negative cosine of x. But then when I integrate again, this would be my next uv, this would be my next uv, this would be my next uv. Now the first one doesn't change, it's going to be positive. But the next one, because of this negative sign, will change to negative. And then it'll change back to positive, then negative, and so there's this pattern of the signs that switch too. So what am I saying? I'm saying that if I were to go through and do integration by parts, this pattern will repeat. I'll have to do integration by parts a couple of times, at least 4 times until I get the right answer. Okay? Alright, so what is the answer? It's going to be x cubed times negative cosine, so I'm just going to toss the negative to the front. And then the next one, so that's just this times this, and the sign is positive. Now for this next one, it's going to be negative 3x squared times negative sine of x. So it ends up with a total positive sign, and it would be 3x squared sine of x. Then the next term would be 6x, right? And it would be positive, so it would be, we'll just say plus 6x sine of x. And then the next term would just be negative 6 sine of x, and then plus c. Okay? Any questions on that one? It worked out when I did problem number 5, and I'll have to go back and redo that example. I took the derivative of e to x, but really I should have been taking the antiderivative of e to the x, which is still e to the x, right?
Oh, I got a way long answer than that when I did it like 3 different times.
Oh, the integration by parts?
Yeah. I got like a really long answer, but my end answer was the same. Like
you probably, there's probably some things that could be combined. Oh. So like, you probably, see like this 6x, I don't know, we could probably, if you want, I'll go over it and doing the integration by parts, we'll just stop the video. But I would suspect you probably have somewhere, you probably have like a 3x sine of x, And then
wait,
somewhere
no,
else
maybe,
you
no,
have
no,
another.
never mind. My thing is the same. Except I have. Shouldn't it be if there shouldn't be two signs in a row? Should there?
6x cosine of x.
Yeah, 6x
Oh.
cosine of x.
Which one did I write?
The one
Yeah,
that
that's my mistake. I just wrote down the wrong thing. That should be cosine. You're right.
And I have it as minus.